programming the processes and workflows. And then we also have some skyscrapers that I was involved in, and the project on the right, it's an office building in London. And it's not, maybe doesn't look so challenging, but the challenge here was that it was placed on top of another building. So it relates to what I will be talking about today. That's why I put it. But yeah, is it okay now?
You're online. I'm not sure about the sound. Yeah.
Okay. Can you change the slide? Yeah. Yes. So you already know I will talk about circularity. So I will explain what it is and why I think it is important, how to do it, can we measure it, and also what is important for us to know when we want to require information. So what information is needed for that use case. Then I will ask you for some feedback, and then I will go. Okay, sorry. So yeah, those are the methods that I will go through. So we will start with some non-standardized approaches, and then we'll go to the standards that exist. So please bear with me. And now, yes, what is a circular building? So I don't know if you have experience. Maybe raise your hand if you work more with information requirements. Raise your hands. Okay, half of the room. And who of you is involved in sustainable design, circularity? Okay, yeah, also half, but some people raised hand twice. Okay, so I will give you this slide to think. I put here 4 pictures, and I want you to think like which of them is the most circular. And I will not give you a lot of time because we spent some minutes at the beginning. Okay, so first of all of them, they are round, but this was just a trick. It's not what I was asking. So first of the buildings, it's from my hometown, from Poznań, and I think it's quite circular. Of course, it's round, but it's quite circular because it was built in the 50s, and since then, it's still constantly being used, and it's always utilized fully. So, like it wasn't abandoned or anything like that. So it's quite sustainable example because it's survived a lot of decades. Next one is my office where I worked for 5 years at the 6th floor, where Bureau Happold has its office in Warsaw, and it's also round. But here I wanted to show example that this building, even if it was not performing so well when it was built 20 years ago, it was then refurbished and achieved certificates like BIM Excellent because it was adapted to new conditions, to new function, and now it's very good building to be in. And then the third example is local here from Canada. I took this picture when I was buying the plane ticket. I took a screenshot. So not a very sustainable structure because it's using local materials. It has almost zero impact on the environment, and you can basically disassemble it quite easily because all of the elements you can just detach from each other. You could build something different from it. So I think this is one of the most sustainable examples that I could find. And the last one is what I got when I asked the Midjourney AI algorithm to generate a circular building. But I think what makes it the most sustainable is that it doesn't exist. So this is also a good example. This is from Norway. It's a Stavkirke, and I like it because it survived a lot of centuries. It was built in the 12th century, but and it survived till that day. So it's still fully functioning. But it was already reusing elements that were 100-year-old when it was built. So it was built using elements from local villages after disassembly of some houses. So it shows that it's not only possible, but it's also like what we used to do in the past. And it also proves that elements and materials, they have a very long technical lifespan that we sometimes don't utilize fully. And if you go to the academia and you ask what is circularity, so we have a lot of definitions. What is circularity? And this paper is 5 years old, so you can imagine how many definitions of circularity we have now. But also we have a lot of ways we can measure circularity. Like this paper mentions 35 of them. So I will give you introduction I really like. And this is that one. So circularity is about like closing the circular flow by reusing elements. It's also about slowing the flow, so using them for a longer time. It's about narrowing by, for example, using less resources, or don't using them if we don't need them, and using materials that are regenerative, so that they don't harm the environment and that we can potentially produce them for decades or centuries or longer. But also, this is a very popular definition of circularity, that it's called this 9R, where you have refuse, rethink, reduce, and so on. But because we have limited time, I will focus on those that I'm most interested in, but I want to highlight that it's not the full circularity. So I will not talk about the whole circularity, just about the reuse of building components as they are, without crushing them, without melting them, not recycling, but reuse. And it's, for me, I think it's important to realize that it's not going to solve all of the problems, but it's also important, and I will tell you why. In this slide, I quote the EU taxonomy, so our European taxonomy, which tells that at least 70% by weight of the construction and demolition waste should be prepared for reuse, recycling, or other type of recovery, which is a lot, 70%. And also it says that buildings and our designs, they should support circularity, so the topic of today's presentation, and demonstrate disassembly or adaptability techniques, which is not very popular when you go and ask architects or structural engineers. And it also says that it should enable future reuse and recycling. Okay, but it doesn't answer why. So I will give you some pictures first and then some data. So I asked the same algorithm, okay, what is the future sustainable building and construction site? And I was surprised that all of the answers were underwater. So this is one of the reasons we could think like, okay, if based on our literature and our images, it imagines that in the future we'll be underwater, that's giving us some warning. But of course, it's more like a joke, sorry. But for example, if you look at the country overshoot days, so it tells us, it's a way to visualize how much resources we are using and how much we are utilizing our planet. And if you look at Canada or Norway or any country that you can see here, we are basically utilizing what's available way before the end of the year. So for example, in Canada, it's the country overshoot days on the March 13th. And some countries are not listed here. That's because they are not using all of the capacity of their country. So they are, let's say, more sustainable. But if you are wondering how it's calculated, I can give you a bit of information, but let's make it like this. So basically, it measures both the land use, it measures the potential to not digest, but process the greenhouse gas emissions of the country, and a lot of other factors like food production, imports, exports. So it's taking into account a lot of factors and trying to simplify it to area of land that one person needs versus the area of land that the country has. Okay, so I mentioned greenhouse gas emissions. This is what the AI thinks it looks like. I don't know, honestly. And yesterday we could hear at one of the presentations, actually not only one, but more, that buildings are responsible for a huge chunk of the greenhouse gas emissions. And here I demonstrate how it looks for Europe. I don't know the Canadian or like broader picture, but for Europe, buildings are like responsible for 1/3 of the emissions. And when we look at this 1/3, 11% of the total, but 1/3 of the emissions related to buildings are the upfront embodied emissions. So most of it is operational, so what buildings consume during their operational phase, but 1/3 is what buildings consume to be produced and for the materials and so on. So I will talk about this 11%, but not even that. I will talk about less, but I will go to that. Okay, but often when we speak about greenhouse gas emissions, we forget that there are a lot of other factors that are important. So when we focus so much on the number about greenhouse gas emissions or global warming potential, we tend to forget about, for example, biodiversity or eutrophication or water crisis, biodiversity loss, and so on. And all of those that are highlighted are somehow addressed by reuse of building components. But I often hear that question, so can urban mining, so basically mining of the buildings that exist, replace all the new production? And the answer is no, definitely not at this moment, because basically we build more than we demolish. This is very straightforward. So when it comes to Norway, we build more or less twice as many buildings as we demolish, and still of that orange part, of this half of them, many of the materials are possible to recycle, such as, for example, steel. And reuse is only going to address part of it. But I think it's an important part. So if buildings are responsible for 1/3 of the emissions, and 1/3 of that is related to materials and construction, and we only reuse 70% of that demolition waste, it's still 4% of the total global emissions. And 4% is, as we could hear yesterday, twice more than all the aviation industry, so planes and so on. So it's still very important issue. And I also have here the material flow. You could see it yesterday for the global perspective. This is for just EU, and it shows how material flows in the industry. It's not related just to construction, it's general material flow. But you can see here that from the initial 15 tons per person per year, only about 1.5 ton gets to the landfill, and more than that gets recycled and backfilled. But the most of the materials that we use, they go to material accumulation, so they stay in the building for many, many decades. And a lot of that is emitted to air. So just to give you a perspective, what numbers we are speaking about. And when you look at Norway, it's a very nice country and it's not so dense, but when you look at the demolition waste, it's basically doubled for some materials in the last decade. So we have more and more demolition amount in mass. And now I gave you a bit of reasoning why I think it's important, and now I want to tell you how to do that. And I have a very simple answer. So we need to separate the technical lifespan of elements from its functional and economic lifespan. And this is not something difficult to do, but basically buildings, they have technical lifespan, which basically tells that how long they are possible to be used when it comes to safety, when it comes to the technical performance. But there are also other reasons why we demolish buildings, and one of them is the functional lifespan that it ends. So, for example, the building is no longer fit for the purpose. Nobody wants to rent it, for example. Or there are economic reasons. So, for example, that it generates more cost than income. So, or it's not generating enough income compared to cost. So those are the key reasons why we demolish buildings, and it's not the technical lifespan that dictates that. And I also have this definition how to do that. There is ISO standard for that. It tells us how to design for disassembly and adaptability. And I wanted to show you some insights from the standard, but I think it's too difficult to read. So I gave you this image. This is from the Lego movie. I don't know if you have seen it. And this is sorry for the spoiler. This is a Lord business, and his mission is he's a villain, and his mission is to glue every Lego brick together so that you cannot disassemble it. And this is what we tend to do often in the construction. And the idea is to not glue them, but to have them reversible and to be able to disassemble them easily and reuse. Okay, and this is a nice representation of how to do that from Norwegian Statsbygg. And basically, it requires some new processes that we currently don't often do, such as doing the reuse mapping, so mapping what elements could be reused in the future when we disassemble or demolish a building. And the second one is to basically do the reuse of those elements in new design. But also there is a part that is not represented at this diagram, which is designing our elements for the future reuse. So not only using what already exists, but when we design a new building and we still use the same techniques that we do, how to prepare them for like easy future reuse. So how to design them for disassembly. And we did many interviews with people who already practice circularity, so people that already reuse structural elements on their projects. And there are a lot of barriers and challenges with that, but also they prove that it's possible, and sometimes it's even cheaper than using new materials. So it gives you, it makes you think that, okay, if it can be here, why we are not doing that? And one of the things that they often mentioned was that we need to start doing monolithic techniques, and we should think about standardization of elements to have more repetitive elements. And I also found some Finnish reports that say the opposite, that we shouldn't standardize, because if we standardize, we will end up with only few options. And if we don't standardize, we will have very equally distributed set of elements to use. But this is just to give you some perspective. And now I will tell you what I do in my PhD research. So since my background is design automation and BIM, and now I focus on sustainability and circularity, I try to combine those two in my PhD. And this is one of the case studies that we do. It's a building that will be constructed in Oslo. It's a very small building, timber building. But what is interesting is that all of the structural elements, they will be reused. So, for example, the facade is coming from a Biennale in Vienna. So the facade is really nice, and it's going to be reused for this time already, because it was used in a build in Japan, and then it was brought to Vienna, and then to Oslo. And the structure will be reusing elements from a farm from Norway that is around 100 years old. And what we did is we did scan all of the elements, not all of them, but most of them, using a 3D scanner, so that we have a digital representation of what exists. And you can see that it's not as perfect as a new element. So we often design these abstract elements that have perfect dimensions, but this is what we end up with. We want to use old elements. And this is the design model, simplified. And those are the elements that are available after scanning. And one of the methods that we use, we try to map them using some design automation. So we try to map all the elements to the new design. And of course, this is in slow motion just to give you understanding how this process works. But basically, we don't want designers to spend hours and hours on picking elements. We want them to focus on what's important, so actual design. And we try to support them with some methods that will simplify the process. And we investigate multiple methods, from graph mapping to other, including machine learning. But it's a very simple process, so we don't need actually that advanced techniques. But what's important is that, for example, here we need to, because it's timber, we need to allow that some elements might be split in half or in many parts and reused in different locations. So we don't only take the exact dimensions, but we also allow for cutting. And the next project that I'm involved in is about measuring circularity. So I mentioned to you that we have 35 ways how to measure it, at least. And out of those, many of them, they focus on the LCA, so about life cycle assessment. Some of them, they focus on this material circularity index. And this is also what we used in our project. But before, I will show this slide from Artur. I see we have some representative from Artur as well here, which is a circular buildings toolkit. It's basically a site where you can see different methods how you can make your building more circular. And here are some of those. And in my project or in projects, we focus mostly on designing for adaptability, disassembly, and reducing the use of virgin materials by reuse. And yeah, the project that intended to develop some easy tools for designers to measure circularity, it just finished 2 weeks ago. And basically, it uses the well-known in the industry material circularity indicator, but then converts it to, translates it to building case. So first we need to start with the material circularity, but then we calculate it for each element in the building, then for each system of elements, and at the end we can finally calculate the global building circularity indicator. But you don't need to memorize I will not calculate it now. But basically for the user, what he needs to know is what informations are important if you calculate it. So this is some of it, but most of it. We did a Reddit plugin, actually Dynamo script, to be honest, that basically allows to calculate circularity of a project, even if you have no information about those. So we assume some default values that are conservative, but the more you know, the more real data you put, the better score you can achieve, or worse in some cases. But basically, the information that we need, they are not often found in BIM, like the connection, if it's a dry or chemical connection, and so on. So those are the requirements that we want to ask. And this is one of the results. We also produce an Excel for people who want to see where each number came from. But important here was that this is just one project. There's a lot of different names for materials. So what to do is to translate, for example, wood frame into timber, because we have data for those materials, but we don't have data if we don't know what's the material, such as, for example, for door, we don't know what's that, so we need to make some assumptions. And yeah, here we can see that this materials indicator, it has to look at the tiny materials that are embedded in each product. So for example, here you can see one door, so they have the same ID in IFC, but it consists of 3 different materials. So we need to calculate the circularity of each of them, considering how easy it is to disassemble this glass from wood and granite and so on. So yeah, some of the methods require us to make sort of dictionary, but I will get back to dictionaries when we speak about information requirements. And this is more or less how it works. Just check the time, it's okay. So you just put the basic information in your model. It can be different software. I don't want to promote any, but then it generates you a report and also visualization of the result in your 3D model. So if you're interested, let me know. I can send you the link, because everything is open source. You can reuse and extend this program if you want. And based on that, based on those 2 projects, there are more, but we don't have time for all. Based on that, I wanted to list the information that is required if you want to reuse building elements in the future or now. So the list is yeah, it starts simple. So we need to know the geometry, dimensions, and so on. Then we need to know some things, some aspects that are important for architects, like color, texture, the acoustic properties, and so on. There are also some regulations that tell you that we need to have this CE mark. I know it's only in Europe, but it's like a certificate of a product, which is difficult when you want to use old elements. Yeah, fire resistance and so on. But the list goes on. So we need to know the material properties, how much was already recycled, like coming from recycling and reuse and so on. Data about the structural performance, because it's not so easy to tell if you have old elements, because we don't know the history of it. So we need to know a lot of information that is not easily available right now. Yeah, if you want to do LCA, you need to know a lot of environmental aspects, and you need to know what's the end of life strategy. And when you want to speak about circularity, if you want to take a picture, I can show you all of them. And the list is not complete. I know that. but basically, can you imagine having all of those data points for each element, like each, for example, timber beam in your project? That's difficult. And there is more to that. So if you think that we all agree how to calculate, for example, LCA, we don't, because this is a nice representation of that problem by Rumble. They showed that in each country, in each certification system, we have different assumptions. So we have different ways how to calculate even the simplest carbon footprint of element. So it's not like one parameter in your IFC that you can just fill. There's a lot of information that is required. And this is what I wanted to tell you about circularity. And now we will go to the information requirements, so how to ask for that info. But before I do that, I would like to ask you to fill this survey. And it will take from 6 to 8 minutes. I know it's long, but it will help me a lot in my work. And I want to know what do you think about information requirements and how to apply them before I tell you what I learned during the process, the projects that we had. So please do the survey. Also for the people online, I would like you to do that. And yeah, I will not speak through like during this time, but I will show you this video. It will be sort of oh, it's scrolling. It will be sort of like a hourglass that will track our time. So it's a demolition of a building. So you have a deadline in mind. Okay. So yeah, I see that some of you are finished. If you are not, I will. Yeah. Please continue. The survey is important for me, and I treat you as people who might know much more about these things than I do. So I really, I would like your input. But I will continue with now the part about information requirements. So we know why we want to require some information and what we want to require. And now those are the quotes that we had from some of the interviews from the people that did practice circularity already on projects. And they really were complaining about BIM information modeling support on projects, and that we lack overarching information knowledge sharing between companies and between the industries, that we need a good software, we need a knowledge base, and that they have to do a lot of assumptions because this data is not available. So I looked at what data is available. I also have some bias because I work in the design for 6 years, and I also know what we did on our projects and what we didn't. But this is example from one of the Norwegian projects. It's from the BIM project. And this is one of the prefabricated elements from IFC model. So you can see it contains a lot of information about geometry. We see the shape. We see also the product information, like who produced it, what's the type, and so on. So we have some basis for the information, like for the knowledge base as people wanted to have. And then we also have the price information. This is for exactly the same product. I Googled that type. So we can see what's the price if you want to buy it. We can find EPD for that product. It's exactly the same product that I found in Norwegian EPD database, and it contains a lot of information. And these tables, it's like maybe 10% of the data that is in the EPD, so environmental product declaration for each product. And I cannot imagine putting all of those into IFC model. So we need to think how to do it right. And yesterday we could hear multiple times, I think I counted 6 times, about material passports, digital building logbooks, about material banks. And when I ask people, I often get different answers. So we have different concepts in mind. So some, they imagine like a database of products from each producer. Some imagine like one material for a building that consists of smaller material passports for each product. Some think about different documents. So I have, again, for you, like some food for thoughts. So how many material passports do you think should be there? I don't want you to answer, I want you to think. And this is a timber wall, CLT wall. Now we have 2 walls, so is it 1 or 2? I don't know. if we have different materials, or if we have multiple layers of one product, let's say, of one element, what if we have a lot of elements? So is it suddenly 7 material passports or 1? So those are the questions that people who are familiar with the topic, they couldn't answer because it's not very concrete definition. Yeah, so is it building a material passport? What about material banks? Because we hear material banks a lot. And in this project in Oslo, this Loka project that I showed you with reused timber, we also have a timber material bank, which is like a pile of timber elements that we can use, that we scan. But when I ask people that are experts on the topic for this material bank, I have different definitions. So one says that, okay, you reuse the building that exists in a place and you build on top of that building. So you reuse the materials from the same source, or you can use materials from different deconstruction sites. But some people say that we should have one material bank, which is like a physical storage space, also sometimes called reuse material marketplace in the literature. And some people imagine it as a digital representation of the available buildings that are still not demolished. So the buildings that are still functioning, but they have like an expiry date. So you know that in 5 years, this building will be demolished, and you will be able to use that element in your design, which is actually also makes sense because we often design much in advance. So yeah, there's no one explanation of that. But if you're interested, I recommend going to, there are a lot of nice guidelines and books about that, like Building as Material Banks is one of the projects that was investigating that topic. But now let's go to the information requirements. That's why we meet here at the Standard Summit. So let's say I want to ask for a very simple information, like I want all of the load-bearing elements to have reversible connections. How can I ask for that on a digital construction project? So when I looked at Norwegian Statsbygg Simba, it's like a set of requirements for public procurement. Yeah, and it's actually called Simba, and it has a Norwegian explanation, but I don't remember it, sorry. It basically says that a wall should have basically a parameter that says if it's load-bearing or not. The wall doesn't have to be load-bearing. It can be set to false or true, but it has to have the information if it's load-bearing or not. And it's actually the same we have in IFC. It's also requiring that property. And then if I go to this standard that I represented to you with the Lego movie about design for disassembly, we see that they also say that elements should have information like a yes or no information if they can be reversible or not. Of course, it's not that simple, but that's what the standard says, that we should have this information in our digital models. So those are two very simple data points that we can ask. Both are yes and no parameters. So how can we ask that on new projects? So one way is to document it as I did on the previous slide. Another one is to make like a Excel spreadsheet where we just list the properties and we give it to the designer and we ask for that data. We could also add to that the stage when we want that information. We could do that, but if we do such a spreadsheet individually on each project, we don't share it with the industry, it will basically make our work only like specific to one project, and we should share. That's why we have open BIM. And one approach that I also see a lot is to code it, to make like a Python or C# or Dynamo or Grasshopper script that will basically test if our models comply with the requirements. I admit this is what I did also at some point, but you can define everything you want in a code, but again, it won't be really reusable. I mean the code, not the elements, because we need to have some like common agreement on that. Another form is to use the software that exists, and I tried to list software that allows us to require information and validate it, and the list is definitely not complete. There are a lot of ways to do that in commercial software. Some of the software is open source, like the IFC tester, that I'm biased because I had to develop the IFC tester. But those softwares are really good. They allow us to do that. But I wanted to look at what the standards say, because we do have standards for that. So some of them you are familiar with, some of them I think are less known, but I will make like a comparison of them in a moment. So let's start with the ISO 19650, our holy grail of BIM standards. And it tells us, okay, what is information requirement? It's a specific in what, when, how, for whom we need to produce. When it comes to information, we have the level of information need standard that tells us what is the validation and verification, how they differ. So for example, for validation, it has to be for a specific intended use, and it has to provide also the confirmation if the model is compliant. We have those diagrams in ISO 19650 that tell us, okay, how to structure these requirements, where to put that, how to structure our documentation. We should prepare like a project-specific, for example, exchange information requirements, and more organization-specific that are not related to one project set of information requirements. So for example, let's say your company wants to measure circularity of all of your projects, so they should define like requirements for that. But also ISO 19650 mentions level of information need, and this level of information need is something that is basically extending that by telling us how to do it. So it's telling us how to document the requirements about the geometry, the alphanumerical, so text, digits, information, documentation. And yeah, I have here one slide about that, but I wanted to highlight this line from the standard, telling that the purpose of defining level of information need is to prevent delivery of too much information, which I really like because I'm a fan of keeping models simple when we don't need them to be complicated. And this is an example of how you can use level of information need coming from the UK BIM framework guidance. And basically here, for example, are information needed for the environmental management, like you have to prepare a carbon report, it should be in a PDF, which I don't like, and it should be prepared by this and that party. Of course, we cannot avoid PDFs, but I'm looking for more digital way of requiring. And we also have data templates, sometimes called product data templates, which is like a way to standardize our spreadsheets. Also, we could use different software for that, not only spreadsheets, but basically it tells us what metadata is important when we want to list all of the properties that each product should have. For example, a window or a wall should have information if it's load-bearing. And this is a template. If we take a template, we can populate it with data and put values here, and then it becomes a data sheet. But also we have commercial software for that. This is one example from a co-builder that allows you to share your data template with the industry, to share, like, for example, what are the properties needed for each window, and so on. So we have ways to do that. We have data dictionaries, which is another, which is based on two actually standards, and it is like a way to share with others some common understanding, how we understand some concepts. Also, it allows to share classifications, and also I learned recently that it allows for sharing the like material definitions. So this is something that we struggled on the Portuguese project that I mentioned, that there was no one way how to name materials, so it was difficult to use some generic data for them. So data dictionary I will refer to also later, but I wanted to mention that it's available at buildingSMART website. It's a DSDD, so like one implementation of the data dictionaries. And what you could do is, if you are into coding, you could use the API and ask for a specific, you could call it requirements or definitions. That, for example, I put here this example with load. It has to have property about load bearing, and you can list all of that information using API. And also we have information delivery manuals, which is like a standard that tells us how to describe our whole workflow, let's say. It consists of those maps that are in the, not UML, building process model notation, BPMN. And this is a way to structure your processes and to tell when you need to exchange requirements and when you need to exchange information. And this is example coming from the prefabricate concrete IBM, which is available, and it's basically a way to structure, okay, what it takes to produce a prefabricated concrete element, what information needs to be passed, for example, to the manufacturer, and what should be passed back to the designer, and so on. And it has this definition of who, for whom, when, and what should exchange. And here, the exchange requirements is one part of the many parts that constitute information delivery manual. And it also says that you should define your exchange requirements using MVD, which is model view definition. And I put here, sorry, before we go to MVD, I also have here an image that shows you how IBM XML, which is like a data readable like format to structure your IBM, what it has. So it has the use cases. For example, use case could be that manufacturer should pass the information about the quality of the concrete and so on. And in that use cases, you should have like process maps, which are those diagrams in BIM. It should have interaction maps that also have transaction maps and so on. But it also has this exchange requirements that are supposed to be extended in MVD. And MVD is like the idea of model view definitions was to select a subset of the full IFC schema for a specific use case, but sometimes also to extend it with some concepts that were not in the IFC schema. But this was a way to somehow standardize parts of IFC that should be implemented in the software. So for example, when you have a software to calculate circularity, you don't need to have all of the information about IFC, so you could only implement the MVD specific to circularity calculation, which I don't know if it exists. I think doesn't. But here is what MVD XML consists of. So it has these concept templates that are telling you what concepts should be in your IFC model. They have definitions, they have attributes and constraints. It also has this model view with concept rules, and I must say I'm not expert on that, so I won't tell you all the details. I only try to understand it. But it also has this exchange requirements, like one part of those model views that have like requirements, what information should be attached to each concept class of elements. And you could also ask for specific, for example, values. You can constrain them. So it's a powerful, but to me, okay, I will go back to that. And okay, requirements. And this is a sample from an MVD XML. Of course, it's only one. It's not a full MVD XML. It's only one part, but it tells you that you can define this template rules with parameters that will allow you to specify that, for example, you should have a property called load varying in a property that's called common with a value that has to that needs to exist. So the true only means that it has to exist. And what I've heard from buildingSMART recently from Leon was that MVD is a definition of what software needs to implement, and exchange requirements are placed on top of that, as you could see on the diagram. And there can be multiple exchange requirements on top of the base MVD that could be added to it. And when you look at the IFC, for example, IFC 4, you can find also some property templates within IFC schema. And this is a diagram taken directly from IFC documentation. So you can see that property templates, they are, they could be complex or simple. And they are like a template to define what information should be for each class of objects. So then you can populate, using them, you can populate your property sets when you define your model view definition or your IFC data structure. But actually, I haven't heard of that before I really dived deep into it, and I asked some experts, so I wasn't familiar with that before. And also, we have another standard, which is ISO 12911, which is about the implementation of BIM in organizations. And it also has a way to define exchange information requirements or information requirements. And they are expressed in form of clauses. Sorry if I pronounce it wrong. And they should follow this, it's called race structure. So requirements, applicability, selection, and exception. And this is something that I'm quite familiar with because this is what my PhD supervisor was doing in his PhD some years ago. And also we have some other experts sitting in the room next to us that are familiar with it. But what's interesting about that one is that it also tells you that each requirement should have this applicability. So it should say what elements it applies to. So for example, walls. It should also have a selection, but it doesn't have to. So it can have selection. So selection could be that all the walls that are on the second level or all the walls that are underground and so on. And you could have also exceptions. So except the glass walls. So this is standard that you can use if you implement BIM in your organization. And this is one example taken from, based on the ISO 12911 new version, which is still being the draft or is still not published. Basically, you structure it in the form of text representation of your requirements, but it's important to distinguish these clauses like applicability, exception, and so on. And here I try to express our use case. So walls should have load-bearing property and irreversible property in them. But then there is also another approach to not only information requirements, but the whole modeling of the data, which is linked data. I don't know if you're familiar with it. Basically, linked data, what I could read from experts on the topic, it's supposed to lower the barriers of data silos in our industry using this graph representation of data. So yeah, I don't know if you're familiar, but the concept is that you should have all of your data represented in a form that is graph representation, and each link between elements should have its own sort of URI, resource identification, or ID, but it's basically a technology that is made for web applications or web use. And when you are dealing with linked data, so let's say you are already using that for your representation of your model, there are multiple ways how you can structure the data and how you can require information to be in that linked data representation. One of them is with shackle, so shape constraint language. And it's similar to MVD XML for IFC. This is a quote from one of the papers, but it's not the same, of course. But also we have different ways like Sparkle queries, which are a bit more like complementary to shackle. But what could be added to that is that this technology, this approach, basically to express information, is being developed by the World Wide Web Consortium, and you can also define your requirements in this. And I tried to do it, and first I need to give you a bit of the background how to get there from your BIM authoring software, for example, Blender BIM. So you have to export it to IFC form. Then you need to convert it to resource RDF, and then it becomes this turtle file. Of course, this is not the only way. There are different ways. You could go directly from your Revit to, for example, IFCO. You could skip the IFCO and go use different ontology to express your data. I tried to list here some of them. So like building topology ontology and so on. And this building topology ontology is represented here with this nice picture the World Wide Web Consortium, which basically tells you that each element should have these links between each other that are relations between them, more or less. Sorry if I misinterpreted some of this technology. I'm not an expert on that, but I did try to require information about load bearing and reversibility. And basically, this is how it looks. This is a shackle query that tells you that IFC walls should have these two properties that could be, I don't know if I made a mistake, but basically if it fails, it will give you a warning that you are missing some information. But again, it's not only requirement that we need to do, it's also how we structure the data. And I will show you an example with linked data at the end of my presentation. But then we go to the topic of new standard, which is quite new. Actually, it's already 2 years old, more or less, I think. And it's called IDS, Information Delivery Specification. And I'm biased because I was using that technology in my project, and I was involved in the development of the implementation of that. But it has some nice features that I didn't find in the previous one. It also lacks some of the features. So the idea with IDS is that you specify your information requirements in a way that is machine interpretable. So you don't only have machine readability, so that the machine can read your data, but also machine can interpret what it means and how to check if your model complies with it, which is also present in other methods to require information that I mentioned before. But I will show you how to do that in IDS because I'm familiar with it. And when you define your requirements in IDS, you can then run the validation of your data. And if it fails, you can generate a report, for example, in DCF, which is another open BIM standard. And in the future, it should also be involved in the export of IFC process, where you define what properties should be there and so on. And this is what IDS consists of. So information delivery specification is also in XML format, which is often used for those standards. And it consists of course, some information you can put. For example, you can specify if it should follow, if the model should follow IFC 2.3 or or 4.3, or if it should be independent, which is what I wanted also to have, because as a person that is only interested in the circularity, I don't care if it's IFC 2 or 4, but I want to define requirements that are applicable to all the projects. And IDS consists of those specifications, which is basically each specification needs to have this applicability, so similar to the race structure, and also requirements. And they both consist of the same sub-elements, which is we can ask for entity, classification, property, and material. So for example, we can say that all of the walls that are walls and that have material timber, they should have this and this classification and property. Yeah, this is one simple example. And if you're interested to see more about the development of IDS, which is currently being, I think, the process of finalizing. I think it's almost finalized. You can go to the GitHub of buildingSMART and see the current development, all of the discussions that are happening. You can also contribute if you have some suggestions what should be in the IDS, which I recommend you to do. And this is another way to put it. So this is from our example. IDS can be interpreted by human, so you can have this human readable form that says, for example, all of your walls should have a property load bearing, and this should be in the property set wall common, and it could be of a value true or false, which you can also see in the XML form, which is human and computer readable, but is also interpretable because there's only one way how you interpret that in your implementation. Of course, if you don't make it wrong. But okay, I wanted to show you how you can use the tool that I was starting to develop, which is IFC Tester, which is a part of IFC OpenShell, open source library for IFC. And I did that last year during the summer when buildingSMART was working on, I think version 0.4 of the IDS, which has improved a lot during that year. And this is how you can use it in Python if you're familiar with it. So you can create your specification, add applicability clauses to it, property requirements, and then you could save it to your XML. This is one example, but of course you can also add more. So you can add some URIs. So for example, links to buildingSMART data dictionary, you can add some instructions, and you can also form restrictions, which is, for example, enumeration that has to be true or false, or you can add regular expressions. So you could say, for example, that your value should start with digits and then it should be followed by some letters and so on. So there are a lot of possibilities, but it's also quite simple to start with. And after you have your ideas, my ideas defined, you can validate your model. In this case, I'm opening the IFC model from my desktop using IFC OpenShell. I run the validation, and then I can show results in multiple ways. One of them is to just print the results in the console, but I can also download the HTML report, or I could make a DCF report with a camera view where this problem is in my IFC model and so on. And those are ways how you can display your problems, when your model is not compliant with the requirements, console, website, or DCF, which you can open in any other DCF supporting software. But I also, to summarize my project, which I did last year during the Google Summer of Code, so it was sponsored by Google, is I did like a user interface that you can use to define your IDS and download it. I must say it's not updated to the latest version because I didn't have time, but if you're interested, you can use the QR code and test it and give me some feedback by sending feedback to my email. But basically, it allows you to specify all of the things that are required for IDS. You can also see how it looks in the human readable form. So you can display it, but you can also download the IDS file and just use it to validate your models and make reports if your model is compliant. So in the meantime, on the screen, I did create IDS file with all of the information that I wanted to require that I can use to validate the model. And then, not much time left for the questions, sorry, but as Leon mentioned, we did a comparison of those methods for a conference paper in Australia this year, where we took into account, we took into consideration multiple aspects that are helpful for requiring information, such as constraints on values. So as I mentioned, enumeration, range, patterns, some metadata that is important, such as the process maps, or other aspects such as how expressive can be in our formulation of requirements, what's the technological dependency or agnosticity, and so on. One example, for example, what is existence in our criteria is that some standards, they tell you if your requirements should be like universal or not. So for example, in this case, depending on how you define your requirements, you can have different interpretations of that depending on your methodology. But if you're interested in that, because we are limited on time, I recommend you check that paper, which is co-authored with Leon and also Thomas Friedman, Artur, Agni, and Andre Borman. And this is one visual way to summarize the paper. Of course, this is sometimes harming those dots because you cannot actually express it with just yes, no, maybe. But it gives like a broader picture. But important here is that some of the standards are still being developed, so they are still in the process of some final edits, such as IDM, XML, IDS, or level of information needs. I don't know if something changed since we wrote the paper, but this is also other visual summary of our paper, which I will try to simplify. So for example, when you talk about expressiveness, so how free are we to define our requirements? We can be more free if we use a text representation of requirements in, for example, in a text document, or can be a bit limited in the spreadsheet because we need to comply with these rows and columns. But for example, if you use IDS or data dictionary, you're very constrained because you only have limited options. You can only ask for property, classification, material, and so on. But some of the standards, they allow for both. For example, MVD, I had to put it in 2 columns because it's both strict. It tells you like how you need to form it, and you are limited to IFC schema of certain version and so on. But also you are free to also put some text definitions that need to be interpreted by experts. And we have to continue. But to conclude, there are a lot of methods to require information on your digital construction projects. When it comes to circularity, I found many of them very useful, but also amount of them also overwhelming a bit, because my information requirements are quite simple. So it's surprising how many methods we have. But I tried to be, as maybe it's a bit subjective. Simplification, of course, those methods, they have different intended purpose, they have different technology behind, and they are made, for example, for different use cases. Like this one is just for implementing BIM, and this one is, for example, level of information need is more project related and so on. But to give you the final slide, to give you, and it doesn't work. Okay, to give you like a summary how I did use the information requirements on our circularity project, I will show you first our workflow. And this is a typical linear workflow, very simplified. So we extract materials, we produce it, design building, construct it, and then after, hopefully, many decades, you deconstruct it and crush and melt all the materials. But if you, doesn't work, if you want to follow the ideal circularity approach, you could recycle all of the waste that you crush and melt, but it's not always possible. So that's why we also have this circular workflow, which is trying to reuse the elements as many times as possible before you go to the downcycling. And there are, as you could see, a lot of technologies that we can use, a lot of standards to require information. One of them was data templates that you can use to define how you want to require the information at the production stage. So what manufacturers could use for defining their data requirements. Of course, you could apply it to different processes in your workflow, but this is one example how we did interpret that. You could use buildingSMART data dictionary or other data dictionaries to link definitions and to have some common shared semantics and understanding of definitions, so that you don't have a problem that we had in Portugal with different names for the same materials. For example, if you are following the let's say BIM approach to building design, we have standards that tell you how to structure your documents, how to structure your information requirements. We have standards that tell you how to implement BIM in your organization. And those standards, they tell us, for example, to use level of information needs to define our geometrical information, alphanumerical, and documents, how to structure them. But also you could use, for example, IDS to require specific information and to validate your models against it, which could also be linked to buildingSMART data dictionary. The same you could do when you design the second building. So when you want to reuse elements, you could also reuse that standards. And if you like to your model to be added to, let's say, shared repository or shared database of your models, of all of the models, you could use the linked data approach, you could express it in a graph representation, and you could use Shackle or Sparkle to require the information to be there. And you could also link that to buildingSMART data dictionary, but you're free to choose. There are a lot of ways. Of course, you don't have to follow the same what we did. But after you define your workflow, your all of the processes, you could specify them in IBM. You could basically do similar to what we did. You could draw the diagram with your processes, so who should send information to whom, when, and so on. And based on that, you could formulate your model view definition so that the whole industry is doing it similar way. So they are using the same, for example, parameters to define carbon footprint or acidification potential and so on. And you could use the technology that is there, such as IFC property templates. And thank you very much. And sorry I didn't leave much time for the questions, but are there any questions? Any questions from the online?
No, I don't have any
Okay.
questions.
So thank you very much. Okay, sorry, one question.
Comment more than a question, but I think where the source of information is and where it fits within the industry would help you in selecting which method you wanted to use.
Mm-hmm.
So for generic materials like concrete, for example, they could be stored in a public database, but then there would be information specific to a project and then information specific to the people it isn't. So
yeah, that's true. For example, when it comes to materials, you could have like national level generic data, which of course you would like to share with the whole country or even the whole region. And when you have producer data that is specific to one, for example, factory plant, that they use this type of energy source and not the other, it's more specific. So yeah, definitely, there are a lot of projects that you cannot share some information, which is understandable. That's why we have different ways how we could ask for the informations to be present in our models. Yeah. Okay, another question? Robin?
Another comment, I suppose. So you put up lots of data, you've shown a lot of detail that people need to do the analysis.
Mm-hmm.
But a lot of that only needs to be done once if information is shared in an appropriate way.
Yes and no. For example, when you design, you do a lot of iterations, so you have to verify the data sometimes weekly. So it takes time to do it manually, of course. If you, for example, have elements available and you want to query like the properties of those elements, you do it multiple times, because in our case, we reuse one building and we build like complete building based only on those materials, on those elements. But I can imagine that we could look for elements coming from multiple deconstruction sites. So you need to do a lot of querying of the data. So it's repetitive, yes. Okay. Thank you very much.
Thank you.